Hey, 9.8, we're doing the sum and difference formulas. Okay, last section. This page 279 of your student journal. I'm hoping everyone knows what a ratio is when you're comparing two things using, we usually use our fraction bar, but okay. Sum formulas. Some formulas say that sine A plus B, so if I have two angles, theta, so for instance, 15 and 20 make 35. Okay, so if I could break this apart, break an angle apart, or even better, let's use, say, negative 75 here. Okay. All right. So let's say I have sine of negative 75, and I wanted to find an exact value for that. What I could do is use what's called a sum formula. Okay, and sum formulas, what we try to do is we try to use our special angle measures to add up to negative 75. So if you think of our special angles, our 30, 60, 90, 45s, and the multiples of those, you're trying to find two that would add up to negative 75. Okay, yeah. Okay, negative 45 and negative 30. All right. So we could use that there. We could say that's equal to the sine of negative 45 plus the sine of negative 30. All right. Now we could go through that process, or we could come over here and we could use the difference formulas. The difference formulas say rather than adding, we are going to subtract. So if I wanted to do the sine of negative 75 again, two special angles that subtract to make that, to make negative 75. For instance, sine of 60 and 135. Those both subtract to make negative 75. Now I personally like to use positive angles if I can. Okay, rather than having to go negative, negative, so I probably use the difference formula on this versus the sum formula. Okay? All right, I want you to just look through those and look at any patterns that you might see or any easy ways to memorize them. Okay. Hey, guys, notice on the sine, cosine, one of the patterns I see on the sine, we have sine cos plus, and when it's a sum formula, we're adding, and then cosine. Okay? Versus cosine, where it's, you have cos, and then you're subtracting. So cosine, just like x a lot of times, is backwards. Right? It says a sum formula, and then you end up subtracting two amounts here. Okay? It is weird. But, yeah, and then the difference one, you add. Okay, so really these are the same things for the difference formulas, exact same pieces, you're just subtracting them on sine, and cosine, exact same pieces, but when you're doing the difference formula, you're adding them. And notice the tangent, very similar in the way you do them. Exact same pieces, just where your addition and subtraction signs are. Okay, so really that's the new piece today, is using those formulas. So you're going to want to have these formulas handy when we do our assignment. So for instance, on problem, or page 280, number 1, hey, negative 75, dude, almost like we prepared. So let's go ahead and work one of those out. Okay. We said that that would be 60 minus 135 if we use the difference formula. Notice it says find the exact value. If it didn't say exact, you could just plug it into your calculator. Find a rounded number. Okay? But it says exact. So we're going to apply our formula here. Okay? So sine 60 minus 135, if we're using our difference formula, you're going to have to, the difference is sine A cos B minus cos A sine B. That's the difference formula for sine. Now, it's probably good to have all of them written down up here, and we'll just kind of write them down as we go. Okay? But this is position A and position B. Think of it as like a seats on a ride or something. Okay? It's a fun mathematical ride. All right. So, sine A. I'm waiting for him to put like Donald Duck in Math Magic Land at Disneyland. That'd be awesome. That'd be like the best ride ever. You'd be like cruising through doing math as you're at Disneyland. Yeah. Just saying.
You're going to say fun and you're going to ruin it with numbers.
Nothing wrong with it. All right. So we plug things in. Sine 60 times cosine 135. Notice A replaces A and B replaces B. Minus cos 60 sine 135. So now you have to think back to the unit circle. What is the sine of 60? What's your coordinate at that place on the unit circle? So if we're up here, this coordinate on the unit circle, that's cosine, that's sine. Sine is root 3 over 2. Cosine is 1/2. Okay, so we want sine. Sine of 60 is root 3 over 2. So that replaces sine 60. Cosine 60 is 1/2. That replaces cosine 60. Now 135, that's over here, and notice it's an angle measure of 45. All the measures of 45 are root 2 over 2, root 2 over 2. It just, you have to have the correct signs, symbols. Okay? So if this is in quadrant 2, which one of these is negative? First one. So cosine is negative, whereas sine is positive. Okay? So if we're dealing with cosine, that's negative root 2 over 2. Make sure you put parentheses around it. You're inputting in parentheses. And sine is positive. And now it's just math. Here are your ratios. Multiply. Root 3 over 2 times root 2 over 2 is root 6. And that's negative. And then 2 times 2 is 4. Bless you. And then subtract. 1 times root 3 is 1 times root 2 is root 2. And 2 times 2 is 4. That is your exact value. Usually you write it, since it has a common denominator, you put the denominator on bottom, and you put the whole piece on top. And generally you'd put root 2 first because it's the okay. So I'm going to write it like that, but just because I'm type A like that. Okay? Stop. Isn't root 2? No, it's negative because it's minus here. Yeah.
So, I may be like completely behind, but where did you get the 60 and the negative 35? Or like, I mean the 35?
Because 60 minus 135 is negative 175.
Okay, but couldn't there be like multiple numbers that go in?
There could be tons of them. The ones that you're you want to use are your special angles around the unit circle. Okay, and there are multiple ones of those. All right, that's.
Like, does it all come down to like one number?
It'll all of them will drop to right here.
Oh, okay.
Okay, they'll all give you the same answer. Then you're not simplifying using this way. Okay.
There's another.
Questions?
Is there another way to simplify?
We have multiple ways. If you can break it into an exact value, we're going to do that right now. For now, you're not going to encounter anything you can't. Okay. All right. I want you guys to try. Hey, will you do me a favor and close your Chromebook and quit playing Pencil War or whatever you're doing? Thank you. All right. Number 2. You guys are almost 10th grade. At the high school, they don't allow pencil. All right. Number 2. You can use a pencil with dice. Okay, yes. All right, I want everyone to come up with some angles that you were going to deal with there. What's up? Anyone have the angle that you're going to use? Walsh? 60 and 60. Anyone else? Yes. Okay, yes. 180 minus 60. Yes. 90 plus 30. Anyone else? Any other special angles around the unit circle that will easily use 120? What about 120? Isn't 120 on the unit circle? Isn't that one of our special angles? Okay, hey, let's not make it too difficult on ourselves. 120 is a special angle, right? So we could just say tangent is 120, or sine over cosine. So let's not make it terribly difficult. We could, by the way, use all of those things you said. It would take much longer. But you could do that. And some of you like doing that. Like some of you like running to Hagen's for cross country when you could just drive your car. Okay? Oh, you guys can't drive yet, so you have to run.
But my brother can.
All right. Some of you can drive. Okay, what is the sine of 120? Good. It is root 3 over 2. It'll help to have your unit circle. You guys, if you want to get better at this and quicker at it, you have the unit circle out. You think, okay, I think it's root 3 over 2, and then you check it. You don't just go right to the unit circle. Okay? Cosine 120, well, if that's root 3 over 2, we know the other one's 1/2. And 120 is in which quadrant? Yeah, it's in quadrant 2. Which one of these is negative? Yes, x is negative there. Okay, so root 3 over 2 times the reciprocal, negative 2. It would be helpful if you can start flipping that in your head and doing that math. If not, write it out like that. Those cancel. You get negative root 3.
I feel like as a faculty versus student game, you should have a sign that says we are, and then it's a radical sign, and then it's for you, so we're rooting for you. No?
Good thinking.
That's so funny.
That was pretty good. Well done, Walsh. Walsh, you're on your way to being a math teacher. Okay. Number 3. Let's take a look at it. Hey, we are in radians. I personally think it's easier for me to think of radians in degree form when I'm doing this. So I go right to degrees. I think, okay, 7 pi over 12. Well, I know that on our unit circle, the smallest unit we go into is pi over which? Pi over 6, which is what degree? 30. So what is 1 pi over 12 then? 15. So what's 7 pi's over 12? Yes, 7 times 15 is 105. So this is the same thing as doing cosine of negative 105 degrees. Those are the same. Now, what that means is since I changed degrees right there at the very end, since it started in radians, are we going to have to change back to radians?
Yep.
Can you change these things into radians? No.
Oh, you tricked me.
Yes, they're going to be the same thing. So really, when you're dealing with radians or degrees, it won't matter if you change it. You're not going to have to change it back because you're coming up with an exact value. They're going to be the same. Okay? So, cos negative 105. I want you to come up with, let's say we're going to use the angle difference this time. Okay? So come up with 2 angles that will subtract to make that. Can I have everyone pause for a minute? I just want to point out what Rachel just said because I think it's a really good point. One that I definitely didn't point out here. Remember your negative angle identities? Yeah? Okay. Cosine negative 105 is the same as cosine of what? 105. Right? Everyone remember that? So as she pointed out, so like I'm just trying to simplify it, that makes it a little simpler. You could either now add or subtract. And I want to use a difference one here because we haven't done it. Oh, yeah, we did do a difference one up here. Oh, I want to use addition one then. I'm sorry. Okay, let's use an addition one. Two things that add to 105. Do we have any? Yeah? 45 and 60. Okay, so let's say cosine, this is going to be cosine of 45 plus 60. Okay, so that's what, this is our A, this is our B. All right, off you go. Figure out what it is.
Oh, this is the weird one.
Bless you. Okay, so we're using the formula cos A, cos B, minus sine A, sine B. So cos 45, cos 1/3 or 60, excuse me, minus sine 45, sine 60. Cos 45, 2 over 2. Sine 45, 2 over 2. Notice I try to use the same angles because I'm thinking of that coordinate already. So, no, both in quadrant 1. Cos 60 is 1/2. Sine 60 is root 3 over 2. It's root 2 over 4 minus root 6 over 4, which is equal to root 2 minus root 6 all over 4.
Hey, that's the same.
All right, I want you to turn to, we're going to skip number 5 and 6 for a minute. Number 4 is part of your homework. Okay? I want you to turn the page. We're going to skip 7 and 8 for a minute. We're going to go on to number 9. Just so you know, the rest of your homework today is 10, 11, and 12. Okay? 4, 10, 11, 12. All right. So, I want you to tell your neighbor what you have to do on number 9. Just so that we all know what we're doing. What do we need to do there? Okay, other than simplify the expression. I know that. They tell me that. So like what are you doing? You could. Pi over 2 is pretty easy to degree. It could be 90, but if you want to change that to 90, that's fine. Hey, you guys, this is set up really well already for you. We don't even have to find the two things we're adding. They tell us the two positions, A and B. It just so happens that A is X, right? So we're going to have a variable in our final answer. Okay? So when we simplify all this and plug it into our equation, remember sine A plus B, that's what we're dealing with. That formula is sine A cos B plus cos A sine B. And then you're just plugging in your pieces. So go ahead and finish that up. All right. This is sine x. Cosine pi over 2. So if this is pi over 2, that's x. This is x. This is pi over 2. Okay? So pi over 2 cosine is, or cosine 90 is, 0. Plus cos x and sine of 90 is 1. Sine x times 0 is 0. Cos x times 1 is cos x. Hey, you guys, do you remember this? This is one of our co-function.
Co-function identity.
It's one of our co-function identities, right? It's a phase shift of 90. Yeah. Okay, you have your assignment. Good luck.